So, welcome back everyone. Hope you had a nice lunch. First, before we start again, I want to emphasize again, please do not bring any drinks or foods into the room. You got a remark last year, so please let's avoid it this year. Alright, so for the first talk of the afternoon, I want to give the word to Jake Valletta, who's going to talk about CobraDroid. So please give him a round of applause.
Alright, does everybody hear me okay? It should be good. So thanks for coming. The title of the talk is CobraDroid, Hooking Android Applications. My name is Jake Valletta. We're going to talk a little bit about a tool I've been working on for about 8 to 10 months so far. It's a tool to help people do a dynamic analysis platform. So I apologize in advance. It's kind of dark up here, so some of the screenshots might be a little hard to see. It's much later on the screen down here. So just a little bit about myself. I'm a consultant at Mandiant back in the US. I've been there for about 2.5 years. While I've been there, I've been able to do quite a few things, from forensics to pen testing to application security. But I really enjoy doing mobile security, so that's kind of why I led down this road. When I have some free time, I like to talk on my blog and my website, blog.thecobradroid.com and www.thecobradroid.com. And I put my Twitter handle on there too, but I'm not good at tweeting or anything, so not much going on there. So just a little agenda for the talk. I'm going to start out, do a little background overview of the project. From there, we'll kind of talk about some of the features of the project, so some of the things that make CobraDroid cool. And then just take about 15 to 20 minutes for a nice demo of the tool. And then we'll kind of close out with some future plans and a question and answer time period. So, for the background overview, the tool that I created was meant for people who want to look and analyze applications. So there's quite a few people who want to do this, right? There's companies who are paying to have their applications reviewed. There are people who are doing malware analysis for a company or even in their own time. And there are also people who are just generally curious about Android applications. So they download an application and it says Angry Birds wants to use the camera. Why is that happening? So when we do an application review or look at mobile malware, there's primarily 2 different phases, where we have the static analysis phase where we look at the code just sitting on our desktop. And for that, we have a lot of tools, right? We have plenty of tools to take applications apart, reassemble them, make modifications, whatever we want. Tons of disassemblers, and that's good. But on the other hand, when we look at dynamic analysis, we don't really have as much tools to work with. There are services that is hard to actually download the called add-ons, basically for additional packages besides just the default Android ones. And you can just unzip the archive there and then launch the Android device editor. And that's the picture on the left. If you've ever created an Android virtual device, basically give it a name, give it a device, some other parameters. And the one that you're interested in here is the target. So the target is usually, it's going to say like ice cream sandwich, honeycomb, gingerbread. In this case, there'll be, if you copied it correctly, you'll see one for CobraDroid 1.0. So you can select that target, push OK, and then you can boot the emulator just like you're booting any other emulator. But you'll be using CobraDroid OS. So with that, now let's pretend you started it up and we're going to talk about some of the features. So I'm going to talk about it from kind of the kernel level down or upward. So we'll start with the kernel, we'll talk about some user space things, then we'll talk about the Valletta VM that I've been working with, and then on top of that, just some Android applications. So when you ask the question, what is CobraDroid? It was basically just a modified build of Android targeting the emulator. So the emulator for Android is much more powerful than, say, the iOS or the BlackBerry simulator, because those simulators, they don't run ARM code, they run x86, which means that you have to actually recompile the application for the simulator. And when we're doing our tests, we usually don't have that. We don't have the source code and the way they're compiling it, so it's very easy for us to take an application off a device or just applying it from anywhere and install it on the emulator and just go. CobraDroid specifically is using Android 2.3, which at this point is slightly dated. It's the gingerbread one, which is the version before Honeycomb. But when I started, ice cream sandwich was still just coming out as very fresh, so a majority of the market was still using gingerbread. Part of my future plans I'll talk about later is moving towards ice cream sandwich or jelly bean or Kit Kat, whatever you want to call it now. So starting at the very bottom, if anyone's ever played with the emulator in any sort of technical depth, you'll notice that the kernel is very old. The code name for the kernel is the Goldfish kernel, and it sits on the Linux kernel version 2.6.29. And according to kernel.org, that was published in 2008, and that ships with the Android 1.5 devices Donut, which, I never even known the Donut phone, that was way before my time, so it's really old. So I wanted to kind of make that a little bit newer. So a couple reasons why I wanted to. First I wanted to kind of play with the kernel and see how it all works and kind of port my own. But there were some features that weren't in the 2.6.29 kernel, specifically the Xtable extension that I wanted for net filters. So I wanted that to be in there. And I didn't want to get too far ahead. So according to the Android website, Android 3.0, which is Honeycomb, ships with this kernel version, so I figured that's kind of a good place to stop and still have the functionality that I wanted. In addition, there were some tweaks to the configuration files, such as enabling loadable kernel modules and a couple other net filter things to allow a lot of network manipulation, which we'll play into the things later. So on top of that, it's sitting in the user space. If anyone's ever connected to your emulator or even your phone, which is running Android 2.3, you'll notice that the shell is pretty bad. It's not a bash shell. It's a very restricted subset of maybe the K shell, but it doesn't have any of the features we want as a tester. And it's fine if you're just going to look at an application, put an application on the phone and do like a PS command or whatever and see what's running. But it doesn't have any really the shell features that we want. We want coloring, we want pipes, we want completion, we want history. And there's none of that on there. There's also no editors built in. So if you want to edit a file, you usually have to pull the file off, push the file back on. It'd be nice to say like VI or Emacs and just have things work. So what I wanted to do is just port BusyBox, which is an embedded systems version of your standard Linux tools, and Bash to Android. And that's actually very easy. It's already done. CyanogenMod already has that on their GitHub repositories. So I just cloned that in my tree and built it in. This isn't really anything groundbreaking here, but what it does is it makes the shell experience much more enjoyable. You can see it's just an ls command. The coloring, we have much more commands that aren't typically there, which will definitely help when we try to do our assessment and we have control we really want. So for anyone also doing memory forensics, which is becoming a much more important thing in the scheme of things, line forensics. File that you get. in this case, command line. It'll send out for testing. This is Motorola. I want my phone to look like it's from China, and I want her to be able to change the phone numbers, change the build properties, and make things work. The way I made this work is the telephony management class, which is provided in the framework, is responsible for querying the radio, especially the interface for the radio and your Android applications. And I kind of just rewrote this to, instead of actually going into the radio and querying for your phone number and your device IDs, instead of doing that, it'll query a file instead. And this file is something you control, so you can say, the phone number is XYZ, when in reality, in the following emulator phone number is 000 or whatever. So that was pretty cool. And then for the build properties, so these are like your manufacturer, your model, any sort of other read-only parameters are stored in a read-only file on the system partition called etc build.prop. And you can only edit this file at boot. So when the system boots, it'll read this file into the build library there, the Windows build, and then it'll populate some static values that contain the values of your phone. So whenever an application wants a model, it queries the build.model variable, and it can use that to get the values it needs. So we can do a little trickery. We can remove that library initialization from the Zygo, which means that this class isn't going to be initialized until the application itself starts. And that means at that time we can actually hook the system properties class to actually return any arbitrary value there. So instead, this file will technically be read when each application is started, which is cool. So now we can point that to a custom file and do the same thing. So on this screen, I have some screenshots. On the left, you'll see there is the device ID. So this is all the radio parameters that I've exposed that you can change. So you can see that there's just some default values there. You can go ahead and change those to whatever you like and to update. In the middle is what I'm calling the property layer, which basically will parse out your build.prop file and let you edit that however you like. And it'll store it in a separate version, so you can always revert back. You can, the next version of CobraDroid, will be able to import this and be able to just take a property file off any random phone and import that and make it look pretty much like that phone. So on the right, I'm just changing the model, which is usually like a Razr or whatever, just to iPhone 5. And it's not practical or anything, but it just shows that you can do something like that should you want to. Okay, so another thing from more of a network side is, when we're doing these assessments, there's a variety of different SSL traffic going on between an application and a remote service. We could have an application that's not using any SSL, which in our case is really easy. You can throw a proxy between it, you can see all the traffic we want to. And then there's applications that are doing SSL improperly, but they're using it, and the fact that they're not checking the host name, or perhaps they're explicitly trusting all certificates. And in that case, we can again put the proxy between it. And then there's this sort of new wave of doing things which is going on called certificate pinning, in which the application is actually including a specific certificate with the application. And that means when it goes to validate the CA and validate the SSL connection, it'll say, is this certificate actually the one that I'm supposed to be trusting? And if we put our proxy between there, it's going to say, well, no, it's not. And it's not going to work, and things might just silently break, it might give you an error. it's kind of depending on how the app's programmed. And there are ways to get around this. Again, we can take our application, we can open it up and take a look at the cert and then replace it, generate our own cert, import the burp cert. We can do that, but then we have to change this for every version of the application we have, and we have to set up all these cert tools to make everything work right. It's still a pain to do. So I thought it would be a little easier to instead rewrite some of the SSL libraries. So by changing the constructors and some of the getter and setter values of the SSL libraries, we're able to have an application think it's doing things correctly. So it's calling the set hosting verifier function, the method rather, and it's calling that method and it's setting up a very secure hosting verifier. But in reality, what it's actually doing is nothing. I mean, it's a void method, it's not returning anything. So in that setter, I just return it, and it thinks, okay, now it's secure. And in the constructor, when you initialize these SSL contexts, it will pretty much just set it to the most insecure way possible. So the application really has no idea what's happening. It's just saying, oh, here's my SSL, here's my hosting verifier, I'm good to go. But in reality, it's pretty much clear text at that point. So that way, when we throw a proxy between this, we will not get any SSL errors. And there's a couple of niche situations where, let's say that they're using their own version of SSL, not included with the standard APK, standard libraries, or maybe they're extending these libraries. Then we're going to have an issue. So this works for all SSL libraries on 2.3. On Ice Cream Sandwich, they included a couple new ones to help with certificate pinning in the browsers. And that's not in 2.3, so that's not implemented yet. But for future plans, that'll be part of it. So I mentioned really early that, and even with the SSL bypass, is that proxying traffic is pretty important. We really want to see what's going on. And because of those net filter rules that I enabled in the kernel, we're able to do a lot of really cool stuff with the traffic. So one of the things that I found pretty tedious was, usually I just had a proxy going between myself and the server, and I might also have Wireshark running on my host system, and just kind of capturing traffic passively, so I have these captures for later. But I'm getting a lot of noise when I'm doing that. I'm getting the traffic from my host, I'm getting traffic from my application, and I'm getting traffic from any other application on the device. So I thought it would be really nice to say, I want to see traffic just from application X, or application X and Y. And that way we can kind of isolate all this noise off, and just kind of see what we actually care about. So we're able to do that, and we're able to take the file off the phone just by doing a maybe ADB pull, and open that up in Wireshark afterwards. So just to kind of demonstrate that here, on the left, we have the interface that we can use where it's basically just a list of all uninstalled applications by package name. You can go in and select a couple. I just have a browser with a calendar selected there. And then on the right top, you can see that I'm just Googling CobraDroid. And on the bottom, it's a little hard to see, I'm sorry, but it says, I'm doing an LS on the SD card, and you can see this file called appcat with the date and time that I'm actually running this capture. And that file will have only the traffic for the browser and the calendar app, so you're not seeing anything else going on. So if I were to ping from the command line, you would not see that in that packet capture. Okay, so now moving into more of the Dalvik stuff. This part is a little unfortunate because I could probably spend the entire time talking about this, but I kind of want to talk about more of the other features that CobraDroid does, and not just muddle them in one space. So I'm going to try to condense this a little bit, so it might be a little technically confusing. But basically, CobraDroid is using method hooking to be able to alert when a method is called. So we have these sandbox technologies you can submit to. I'm sure people have used some, like Cuckoo Sandbox, one of them. It'll tell you what the app is doing. It'll kind of give you like a readout of, it did this, and then it did Y, did X. Great. So it kind of gives us an idea of what our application is doing. So I wanted to have that functionality in your version. When you download CobraDroid, I want you to be able to do that. And not just do it based on what I think you should be alerting on. You should be able to alert on whatever you want. So when you download CobraDroid, you'll get a list of functions that I care about, or rather methods that I care about. But you have the ability to change that file and put whatever you want in there. And this could be for system library calls, but this could be just for your application, just downloading and testing. So kind of the too long didn't read thing here is that we're instrumenting method bytecode during class loading. So if you can't take anything away from this, at least take that one statement. We're instrumenting the bytecode during the class loading period. So, this looks terrible. So this slide would show the configuration file. It's very difficult to see. There are two sections in this file. There's a system section on the top, and there's a app section on the bottom. That makes it a little easier to see. And what's inside of this is a series of classes. So in this case, Android telephony, manager explained that's the class that queries on radio, and then n number of other classes. And on the bottom, the same thing is true for any applications you've installed, you have the class number. And with that, underneath it, you have tabbed in methods. So in this case, in the top, I have get device ID. And what that means is the device ID is the method, and after that is what I'm calling the action. And the action in this case is the only one implemented, which is alert, which I mentioned is going to tell you this method is called. And after that, which is impossible to see, is a string. And that string actually says an application access to device ID. So that makes it easy for you to see that when this method is called in an application, that you're going to see that string, and it'll actually show up in a log buffer, so you can use the Android tools to this cat log buffer, and you'll see that application X did this. And just to demonstrate it, this is actually a little easier to see. You'll see I'm actually catting the security log, which is the log that I added for CobraDroid. And this will have all of the events happening on the device. So on top, you'll see that the application com.jpg.testing, and you'll see that string that we inserted in the last slide, an application access to device ID, and then you'll see the actual class and method afterwards. If you choose to omit a string, it'll just say the method call, and then it'll tell you the method in class. What I didn't mention on the last slide is that bottom one there says, obfuscated method is accessing your contacts. And the reason I put that message for that one is the name of the method itself is nzkds. So if we're looking at an obfuscated application and we want to know what that method is called, it's kind of hard to tell what nzkds does, because it's really not a useful name. In a lot of applications, especially now, we're going to use obfuscation techniques to make sure that we can't look at what it's doing. So now we have this reminder that, hey, this function was called, and it's a really terrible name, but we know that an obfuscated method is accessing the contacts, because we did some static analysis beforehand. So it all works like magic, but it's a little more involved technically. So I kind of illustrate the steps involved, and I have about 6 slides on these. It could be, like I said, it could be 30 slides, but I'll just kind of touch over the main points. So when we start the DVM, which is usually going to occur when the zygote starts, which is the main process on Android. Each application will fork off the zygote. When that zygote process starts, we're going to insert our first hook there, and when it loads all the components of the DVM, we're actually going to store the configuration details from that previous file into some global memory structs. And there's already structures in the DVM that allow this, so it's pretty easy for us. And then the second thing we're going to do is there's a structure that gets initialized at this time that's going to hold all the resolved classes, methods, fields, etc. for our given DEX code. It's a DVM DEX structure. It gets allocated given the actual size, that's required. But we're going to do things like inserting the methods and inserting the strings. So we're going to have to actually over-allocate this. So we're going to calculate how many strings we need to add, how many methods we're going to need to add, and we're going to over-allocate the structure. So later we have room. So the second step, when the zygote begins starting, it's going to actually load all the classes in the Android framework. And that's to save time. When each application starts, it already has a fully loaded instance of the DVM, which means that every application doesn't have to do any loading or initializing. It's already all there. So it's going to actually iterate through all the classes and load them. So at this time, we're going to, in the DVM, we're going to look at the class that's getting loaded. And if the class matches a class from the configuration file, we're going to set a flag in that structure, and we're going to keep going. As the class begins loading, it's going to load each method of that class. So we'll kind of go through all its methods and get those all set up as well. So for each of these methods, we're also going to check the name. If the name matches something from our configuration file as well, then we're going to kind of branch out and we're going to do something. So what we're going to do is we're going to allocate memory for this DEX code structure. And I apologize for these names here. The DEX code structure is basically a structure that initially is mapped pretty much right out of the DEX file itself. The DEX file is all your compiled application code. It's going to map that. It's going to take that whole structure, or the whole file, map it into memory, and it's going to set up all these pointers in that file. Well, one of the pointers is going to be the DEX code pointer, and that's the code segment for our particular method. And we're going to take that structure, however many bytes that is, and we're going to allocate that many bytes plus n, where n is the amount of instructions that we want to add to our new code. So just to kind of show what the DEX code structure looks like, it's not terribly important, but there's 16 bytes at the front, which are mostly sizes and offsets. So how many registers does this method use? how many inputs is it getting, how many outputs, how many tries and catches are in this. And then after that, which is a little more important, is the instructions one. So the INSN variable is an array of 16-bit instructions. So these are our bytecode. It's a little difficult to see on the right, but these are, actual bytecode. So move, register 1, string 4, whatever. So it's all the assembly code, or the bytecode rather, for what this method does. So we care about that section. We're actually going to change the code in this section to do whatever we want. In our case, we're going to insert hooks to actually call another method so that we can see the log event. So like I just said, we've already allocated the space we need. So now we're going to make a call to the class event notifier, which is the class that I wrote, and we're going to call it the notify event method. And that method just prints to the log the name of the application and whatever payload we have. So after we've put the code to do that in there, we have to kind of repair our remaining DEX code. So we probably just copied it all over to begin with. And now we have to make sure that all of our tries and our handlers and our debugging information are all realigned. Or otherwise, if there's an exception, it's going to jump to some random point and everything's going to explode, or it might not even resolve. So that way, we're able to have our code execute before anything else executes in that method. And the final phase that we care about is called resolving. So when our application actually begins execution, it has this list of instructions already loaded in the DVM. And when the DVM actually says, hey, okay, let's start executing this method, it has this bytecode. And for example, on here, I have constant string v0. Actually, step back first. This is a call to the log debugging log. So it's log.d, a tag for where we actually are, and then a string. So in this case, what is going to happen is we're going to load up our registers, 0 and 2, register 1 is not used here, with strings. And these strings aren't actually in line. They're just offsets to a pool of constants that the DEX file knows about. So it's saying, load into constant 0 string 33. So it knows, well, this is the DEXDump output. DEXDump has disassembled and told us that string actually is I am snake. But it doesn't actually know that, it just knows that it's string 33. So the resolver is responsible for finding out what that string actually is, so that I can put it into that register. Similarly, after we do that, we're going to invoke the log debugging call. And that call is the log.d invoke static there. And that's just method 0004. So the resolver needs to determine if that function, that method actually exists in our DEX file or some other DEX file. And in this case, it's another DEX file. We didn't define that method, it's defined in the framework. So that's what the resolver is going to do. So the question that comes up is, how do we call a method or use a string that our DEX file doesn't actually know about? So the message that we're injecting in there, that string doesn't actually exist anywhere unless somehow it did, but it probably doesn't. We need to somehow get that into this DVM DEX structure. And luckily, beforehand, we've already over-allocated that structure. So when we get to the point where we're instrumenting our code, and we know that a string doesn't exist, what we can do is we can say, instead of resolving, string 4, we're going to resolve the string, the max plus an arbitrary number that we're using to identify that payload. So if there are 32 strings, and we only have one additional string we're injecting, we're going to say that we're going to resolve 33. And typically this is an error condition because, the resolver is going to get that. It's probably a segmentation fault. The VM is going to say, I don't have 32 strings, I only have 32. But we can actually catch that exception there. And instead of treating it as an error condition, what we can do is we can say, we're going to manually resolve a string at this point. So we're going to say string 33 is this string that we've injected into the VM. So then when the code executes, it goes, oh, I know about string 33, and it just puts it in there, and it's good. And we can do the same thing for methods too. We can set the method number to the max plus 1 or any number, and just catch that in the resolver, and then we can call methods from other DEX files, or methods that don't even exist, and we can define them whenever we like. So that's kind of just the hooking thing at a high level. I will be putting some information on the website in more detail later, but from a high level, that's kind of how that works. So to get back to sort of the features here, in addition to having all this lower stuff in the Android space, there's also several new applications. So there's the CobraDroid application, which is just a very simple way to proxy applications. There's the super user application, which makes it very easy to get root privileges, which isn't usually possible. There's the new version of Mercury for anyone who's used the Mercury tool is a pen testing tool. It's called Droza. It basically lets you impersonate an Android application from the command line, which is actually pretty useful. You can use it to interact with databases and stuff. And then there's just my front end that I wrote to kind of make all these CobraDroid features very easy for you to use, so you can change your device ID, you can set up the packet cache, etc. So with that, I'm going to kind of roll into the demo here, so hopefully everything works good. Try this over. Alright, so for the demo I have here, so I have this mystery app, I just call it some mystery app. And so here's CobraDroid running. It looks exactly like the Android emulator if anyone's ever used it. And what I've done is I've installed it here, so it's called Test App Now. And there's also some other things here. There's this little bar here, which is some of your configuration options. You can go ahead and turn these on or off. This is going to be to turn on those mods that I was talking about before. And we also have CobraDroid. I went ahead and I've already got that started running. So I'm proxying traffic to myself, just over here in Burp. So we're going to see any traffic without coming off the phone. So another thing I want to do before we get started is I also have a log tag going on the security mode. So I'm going to clear that log out, and I'm going to start that. So this is going to show us any methods I can call to find our hooks.conf file. What's in our hooks.conf file? We can get on the shell here, and we can edit that file. So in here, there's 3 system calls that we know about that we're alerting on, which is the get device ID, get subscriber ID, and get line 1 number of the telephony manager class. And there'll be several classes and several methods in when I actually do release CobraDroid here. But for now, there's just these 3 here. And on the bottom, I have this commented out section, which is going to be the name of our application that we're going to look at in a minute. Okay, so let's close that for now. So let's go ahead and run this application. Actually, one more thing. Let's do one more thing. So I've disassembled the application as well. I used the tool APK tool. If anyone's familiar with Android disassembly, it runs Somali over the dex file, which disassembles that. It unpacks our resources and decodes our Android manifest, which is very useful. So I'm just going to do an ls in the directory where our files are going to be located. And we see the names of them are not very helpful. We have an a.somali, a b.somali, main activity.somali. So the first 2 are some obfuscated classes, and the third one is just probably some activity we have which doesn't get obfuscated. So we know right away that our static analysis probably isn't going to be very helpful because the names are all going to be ruined. So with that, let's finally run the app. So we just go ahead and click on it. And we're presented with this error here. So this error could be if you're testing an app specific for a device or a specific carrier, and it's basically telling us that this app isn't supported on this device. If it's malware, perhaps it doesn't run at all. If it's malware and maybe it's less programmed, it crashes. Something happens, but something isn't working. So we can't even begin our testing yet. So we know that it's doing something to check what kind of device we have. So we can very simply just do like a grep over those Somali codes for the string build. And this string is going to be useful for us because that's the class that I mentioned before, which is going to be for to access the variables necessary to acquire that data. So there's some noise on top, just these string builders. On the bottom, there's one right here, that's Android OS build model. And it's hard to read over here, but that's in the main activity file. So I'm just going to go ahead and open that quick. Okay, and I'm just going to look for model. Okay, so we see here that it's, if anyone's not familiar with the syntax, it's the Somali syntax. It's kind of pseudo-assembly-ish. We're getting the value of the model, putting a register 0, the string razor, putting a register 2, and then we're doing an equals function on those. So it's pretty clear to see what we're doing here. We're checking if the model is the string razor. So now, normally what we would do if we didn't have CobraDroid, we would probably take this line here and we comment it out, or we would make it actually match what our model emulator is. But we don't actually have to do that. So what we can do is we can go to CobraDroid. We can put this little guy here, which is going to pop up through our interface to make our changes. And we can head to the custom build.property. So this is parsed out all the properties of this phone. And the model happens to be right here. And right now it's just a regular revision of CobraDroid. So let's go ahead and change that to string razor. Okay. So we're just going to save that. And now the phone is going to use that value as soon as we enable this guy here. So now it's going to use those values in our file when it actually queries that value. Sorry, variable. So now we can run it again. And this time we don't get an error. So at this point, the application could do any number of things. In this case, it just presents a blank screen and just says the word connect. It could be a game, it could be anything. But what we want to do now is we're going to say, okay, well, let's hit the connect button. There's nothing else we can do here. So we'll click that, and we get another error. And this time it says, there was an issue connecting to the server, and it gives a reason. It says the certificate's not trusted. And recall I mentioned that we're proxying traffic off this device. So the certificate that we're proxying, in this case Burp, is using is not what the application is expecting. So normally now we have to take the application apart again, figure out where it's doing these checks, and kind of finesse it and make that work. What we need to do is actually click this button here, which just says SSL validation. And if you go into the main screen here, there's a button here as well. And basically what that's going to do is it's going to enable those changes to the SSL libraries. So if we run it again now, and we hit connect, doesn't like it's not? Okay, hang on a sec. Last time I did this, my computer must change. Sorry about that, 1 second. The proxy wasn't sitting on the right interface. Oh, let's try something down here. Okay, much better. So now we see that Burp has captured the traffic. There was no warnings. And we see that it's just posting to some site. And in the payload is a couple post parameters. In this case, it happens to be our phone number, our subscriber ID, and our device ID. So I'm just going to go ahead and forward that on. And at this point, I'm going to switch over here to that security logs tab. I mentioned this tab's going to have all those method calls that we're interested in seeing. So we see here, it's a little hard to see this wrapping around, but we see calls to, let's see, the get device ID method, the subscriber ID, the get line 1 number method. They're all in here. So we see that this happens. Even if we didn't see the network traffic, we would know that it's doing something here. So now what we want to do is we kind of want to open up that file where it's doing that. So we're gonna grab for get device ID here. Get a couple of those same files. Okay, and we see one instance of the get device ID call, and that's in b.somali. So let's just go ahead and open up that file. And again, look for that. Okay, so clearly here we see those 3 calls. We see get line 1 number, get device ID, get subscriber ID, and then it's putting it into an array and setting up those post parameters down there. So if we scroll up a little bit, we see that this is a method called A. So it's not a very useful name. If you look at the name of the class, the name of the class is B. So just looking at this, it's not very useful for us what the method A does. So what we can do now is we're going to edit our hooks.conf file. I think I found my mouse. There we go, sorry. Okay, so we'll just go ahead and edit hooks.conf. And at the very bottom here, where we have this commented out section, it's a little hard to see for me. There we go. Okay, so we're going to uncomment what that's there. Sorry, you guys. You're mad at me here. Try that again. Oh. So we're going to add what we just had there. So we start out with our class. So we had com.jp. It was testing app, test app 1. .b, enter tab, and we got A. We're calling the alert handler here, and we're going to make a string here that's going to say application access our device IDs. So it's just something useful for us to have when we actually run this. So let's make sure everything looks good here. Oh, I did that in the wrong spot. Okay, sorry, that was pretty bad. So now that stuff concept updated. So when we relaunch our application over here, we should see those strings, those things happen in the log files. So we're going to start over one last time, and while we're at it, we're going to enable the final node, which is the telephony manager. And if we go into that interface I showed before, we could change the phone number to whatever we wanted here. So let's do that. Just read that. This is a system random number, but in any case, it could be the phone number or a Chinese number or something that it might be looking for on the back end, since we know it's posting those to the web server. Okay, so those are updated. Let's go ahead and launch the application. So again, we now see those new numbers here for our phone number. And that might maybe help us on the back end. Maybe it looks for that number or something. We can see that it's there now. And if we go ahead and look over here, we see this thing here saying that, an application is accessing our device IDs up here. So there's that string we put that hooks that conf file. So now it's magically here, and we see that the method of the class is com.jp_test1ba. So now every time that method is called, we're going to see that here. And that could be much larger. This could be, maybe that was like the logging class that they implemented. So now we're able to see that shows up for any n number of times it's going to be run. Okay. So just to demo one last thing, I got a couple minutes still. So here's the application capture. The actual application that's going to help you just capture specific apps. So let's go ahead and let's find our application in here. And it should be in the bottom. Test that. Oh, it's like, okay. We're going to just go ahead and click enable, and it's going to prompt us for a file name. So this one is give it a little easier file name to write. I'm just going to call this BruCON.pcap, and that's going to go on an SD card. So when we hit save, we get a little notification up here saying that it's running. Now we're just capturing traffic for the specific application. So to prove a point, we can take our app here, we can click the connect button again. Okay, see our traffic. Cool. Let's go back to the home page and let's open up a browser. We're just going to grab that. Let's just Google something. Type BruCON, I don't know if it's there even. Yeah, okay. So we're going to Google something, but this is not our application, this is the browser. So we see everything we can find here. Now let's go ahead and stop our application capture. Okay. And then on our workstation, let's go ahead and grab the file. Okay, and then we can open it up in Wireshark, like I said. So now if everything worked correctly, what we should see is, we'll see our SSL traffic from our application, which is good, we want to see that. In this case, we really can't get much out of this because it's using SSL. But if we look for, say, the string BruCON, because that's what we actually look for, we don't have any results. So we didn't actually capture the traffic from the browser, we just got the traffic that we were concerned about with our application. So that makes it much easier for us to actually see what the app's actually doing, and not anything else, any other noise we're getting in between. Okay, so that's it for the demo. I'm going to continue back on here. A couple slides left. Just for some future plans and research. I mentioned really early that I'm using 2.3, which is pretty old at this point. I'd like to move that to Ice Cream Cell, actually, the Jelly Bean, just to kind of put on a more updated platform. There's a lot of capabilities that we can do with this hooking framework. Instead of just alerting methods I call, we can, what I see in my mind is the ability to have a payload. So when a method's called, when a method exits, you should be able to supply a payload that you've already written in Java, and it'll actually call that code, which will allow you to basically do n number of things, right? So, for example, if an application is trying to resolve a domain, we could hook that method and give it a custom payload that on entry, it will give us that domain name. So we can see that in our logs exactly what it's doing. This will allow us to have a lot more capabilities when it comes to monitoring what an application is actually doing. In addition, there's a lot more man-to-middle things we can do, not just network traffic, but we can also man-to-middle things like database queries. and kind of change them on the fly to make our testing a little easier. As well as I mentioned, the intents are IPC for Android. It'd be nice to see directed intents, which are directed at a single application, just to see what's going on, see who it's talking to. So those are kind of the features that are going ahead. Will be in the new version of CobraDroid. So one last slide as far as getting information. I'll be updating my website, my blog on more details on the talk, and as well as some technical details. As of right now, the project is hosted as the beta version, which is lacking in some of the hooking and some of the applications to the captures. But you can go ahead and download that from my site here, and also the source code from my GitHub account. So when things are all finalized, I'll be able to publish the real full-on CobraDroid 1. But for now, it's still kind of in the testing phase. So you'll have to kind of settle with the beta, or ping me if you want to try out the full version. Your mileage is going to vary very well. So with that, are there any questions, comments?
Hi. I am actually really tempted to compare your runtime analysis with the JavaScript implementation. You get a regular GVM and for the next implementation you're planning with JavaScript, in which one may give you the same like value input parameters and your return value if you change them automatically, call your own classes and lessons and then because for the moment it's interesting, it's not that that's really limited because you can only open in the logs.
Right.
Information for your lesson when it's called. It's fairly limited when you want to be able to use it, especially if you're using HTTP, but maybe another protocol that you won't be able to do.
Yeah, and the JavaScript project you mentioned is actually very useful, but the way it's implemented, they didn't include all those features in the DVM, so it's not possible to port JavaScript to DVM. I'm sure it's possible, but the way they're doing it is not implemented in the DVM. Because I kind of wanted the functionality to be very similar to JavaScript. It's got a really nice interface where you can, inline capture the method and change it, do whatever you wanted at that time, which is much more powerful. So I think eventually, what I'd like to go towards is what JavaScript does as far as that goes. So I agree. Any other questions?
To your opinion right now, what would be could that tool be used to industrialize an attack by identifying what is the security measure of an application and then stealing what is required from a client, identify what is, for example, most applications right now, most of the apps will try to identify the device ID and then you go, well, this is the credential. Can you circumvent those attacks by any other means? Is there any way to provide any unique identification that cannot be replicated in Android?
Are you saying it's like accessing that data?
Yeah.
The tool itself is more towards not actually preventing things, it's more for testing. But there are things you can do on, say, your phone you can change some system files if you have root access and have it not return a unique ID. It's entirely possible.
I'm trying to explain my thoughts, right? I'm saying your tool, I'm saying to myself, well, if I need to, if there's an application that tries to do all those security measures to try to identify, make sure that it runs on the device that the credential that it was running for was it. With this tool, you can actually simulate the device almost quite. So from the app perspective, it will not know that. So then you can launch an attack by just stealing those credentials and then running it and as I said, industrializing it.
Yeah, I think that could be possible, but I'm not sure if that's really, what I would use it for. But I think it's going to be good.
Okay.
Any more questions?
Yeah, what I would be interested in is what was your approach to develop the add-on? Is it like downloading the whole Android open source project and going
Yeah, so the way that I'm doing it is I have the ASLP and I just make my changes and then I build it. And then it creates all the system images for me, and I just include those in the add-in directory. So when you specify the target, it uses that system image and the kernel in that directory. If you wanted to change things, probably the easiest way, I mean, the most flexible way would be for you to download the source of CobraDroid. And I have instructions on how to build it. If you really wanted to change add something or change something, you could just download it and change it and build it and put that in the add-in directory. If you wanted to be a little more tricky, you could technically, run the emulator, pull the libraries off, and then disassemble them, and then kind of play with it that way. But I don't think you're gonna have as much success doing that. I think the better way is to build it and, call it that way.
Thanks.
Any more questions?
So I see that your method is kind of relying on APK tool or backscaling to reverse engineer the information. My question is more about what about apps that cannot be reversed with backscaling? I've seen some probably malware that has like weirdo instruction constructs and stuff that makes backscaling fail. So do you have any ideas for that?
I think it depends. I mean, you could use other disassemblers as well. I mean, that's just one that I find to be useful. As long as the code is installed, CobraDroid won't have a problem running it. As far as doing static analysis, I mean, if you can't get the code to disassemble, then you're probably going to figure out what the code's doing and try to get around that. But I mean, I don't have personally any other choices besides, DexDump or BruCON that are going to disassemble it successfully if there's some sort of bug in the way they made, they structured the dex file weird and things break when I try to disassemble, so not sure if I have anything really to get around that, unfortunately.
Thanks.
Yep.
We have time for